All right, we're looking at number 15 and 8.4. And what I want you to notice first is you might look at a du over u, but that's not going to work because your du, if you had that, would be 2x plus 2, and you don't have a version of that you can work with. So instead, we're going to go ahead and we are going to do partial fractions. So we have a over x times, or plus b over x plus 2 equals 5x plus 6 over x squared plus 2x. And then we multiply it through by the LCD, and we get a times x plus 2 plus b times x equals 5x plus 6. So we go ahead and plug in x equals negative 2, and we get negative 2b equals negative 10 plus 6, so b equals negative 4. No, it is not. Negative 2b equals negative 4, so b equals 2. And then if we plug in x equals 0, we get 2a equals 6, so a equals 3. So we can go ahead and look at this, and we can go ahead and say that 3 over x, the integral of 3 over x plus the integral 2 over x plus 2 dx. And we'll evaluate that. We'll get 3 natural log of absolute value of x plus 2 natural log of the absolute value of x plus 2. And we want to evaluate all of that from 1 to a, and we'll put our limit statement in and do the limit as a goes to infinity. All right, so now we're at the point where we've got all of this set up to be able to plug in, and we can go ahead and move from here. So first I noticed that there's a plus sign between these, so I could just combine these, and then I could also bring both of these as powers up on top. So let's go ahead and do that. So the limit as a goes to infinity of the natural log, and all these values are positive, so I don't need to worry about the absolute values anymore, of x cubed times x plus 2 squared, evaluated from a to 1. And so if we plug infinity into that, we get the natural log of, so we said the limit as a approaches infinity, natural log of a cubed times a plus 2 squared minus the natural log of 1 plus 3, or times 3 squared. And so we get infinity minus natural log of 3, which equals infinity, which implies that the integral diverges.